the first thing we need to do is really to look at the carbon-carbon framework, because in this multi-step synthesis what you see is that, look, you've got 2 carbon fragments, but your target molecule has 1, 2, 3, 4 carbons in a row. And I think it should be fairly obvious then that this is the bond you're making. Yeah, this is the bond made, and more importantly, this is the carbon-carbon bond that's been made. Okay, so what you're looking at is then two of these carbon-carbon fragments becoming this framework. You see, at this stage, I'm not bothered about functional groups. I just want to see how my carbon framework comes down, and then we'll look at the functional groups. Now, therefore, since I'm making this bond here, what I'm looking at then is I'm looking at, say, let's call this fragment A and call this fragment B. Now, fragment A, we can make that the positive fragment and this the negative fragment, or we could make this the negative fragment, or B the positive fragment. And all that means is if I can get A positive and B negative, I will form that that carbon-carbon bond. Or I could have A negative and B positive, and I form that bond. Now, I can't go through all of them, but let's supposing we start off looking at this combination. All right. So what I mean is, I want an A positive fragment. I'm going to call them synthons, okay, and a B negative fragment. That's a B synthon. So what I'm looking at here is, in order to get, okay, I want this side to be positive and I want this side to be negative. So what are my possibilities? Now, when you're experiencing practice, you don't need to do this every time. Well, I can see a Grignard, okay, and I think that's the first one you think of. Now, remember, in our list of reactions, we can also see an organolithium, or even an organocuprate, but I won't list that. We can also use this synthon. Yeah, let's cross that out. So what is that one? That's an acetylide anion. But you see, all these are carbon nucleophiles. That's why they, are the negative fragments. And just to warn you, we have one more coming up later on, and that's this one. This one, okay, is the Wittig. You've learned about Wittig, you will be seeing them. But you see, all of these give a 2-carbon negative fragment. What about on the positive side? What are our possibilities? Again, after a while, you just spot them. You don't have to list them all. But what's a positive fragment? Well, a positive fragment could be something like that, a halogen, like a bromide. Okay? It could also be something like a simple carbonyl. Okay? Or it could even be an ester. You can, this one actually just invite a nucleophile in, and then don't forget your epoxide. Got me? So all of these, you see how they can connect? All of these are nucleophiles, so they attack out. Okay? And then all of these will accept a negative fragment. So you see, these would be attacked in. Does that make sense? I hope so. Okay. Now, the next thing you want to do is you want to think one step ahead, okay, on when the synthons come together. Bearing in mind what we want, is carbon, 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 and you want some functional group to end up on this carbon, not this carbon. You want it to end up on that carbon. So that's why when you're looking at these various synthons, this one, okay, but when this is attacked by a nucleophile, a carbanion, that leaves, and you're left without a functional group. That's going to be problematic. This one, if you attack it, this opens up, but then you're left with a functional group on this carbon, but you really want a functional group on that carbon. Do you see? Sometimes that's all you can do, and maybe we'll do some clever things to shift the functional group. But right now, we have this possibility where the nucleophile comes in here, and then when this opens up, you see the functional group ends up right on this carbon here, which is where you want it to be. So hopefully you can see that our synthons are going to be this epoxide and this one. Okay, so these are our target fragments. So now the question becomes, you see, up till now I was thinking more about how to get the carbon-carbon fragments together, but now that I can see the carbon fragments, what I need to do is to synthesize those fragments. So I want to call this the positive fragment and this the negative fragment. Okay, so remember, you always have to respect what the question wants you to do. The question says you can only start with ethanol. Alright, so for our positive fragment then, positive synthon, the question becomes, how do I convert this one to, what was it? It was this one I want. Okay, for the purpose of this exercise, I'm going to leave out the hydrogens. I'm sorry, you're not allowed to, okay, on the test. So, this is where you really need to know your chemistry. Now, if you've been learning the reactions the way I've recommended, this will make sense. First of all, I want to do a dehydration, okay, and I will get an alkene. And once I've got the alkene, I just need to do an epoxidation, okay, and now I will put in the hydrogens. There's my target synthon, right? So I need a dehydration. You can look up the reagents for that. And I need an epoxidation, and you can look up the reagents for that. Okay, what about the negative synthon? Okay, what I need to do is to take this 2-carbon alcohol, and I need to make it into this fragment. Okay, these are the steps. I'm going to, first of all, I'm going to again do a dehydration, and then I'm going to do a bromination, and with the bromination I'm going to do a double elimination, and then with the double elimination, I'm going to treat it with a base to form the acetylide. Okay, so dehydration again, bromination, okay, elimination, and then an acid base there. You see, now we switch to really having to know your reactions well. This is why I encourage you to think of these reactions as a dehydration of an alcohol converts it to an alkene. A bromination of an alkene converts it to a vinyl dibromide. Know your reactions well. Okay, so now I've got the 2 synthons. Okay, be careful. Think about your any steps you might need to take. What I mean is this: we've made this compound. All right. And we know that if we treat it with this other synthon, we will get the product. Well, that's what we need to do. We'll get that carbon-carbon bond formation. Now that's usually finished with an acid hydrolysis step. But look what happens when this attacks here. That opens up there, and then you protonate. Now you've got your hydroxy group. Okay, not on this carbon anymore, but it's on this carbon. Okay, so notice there it is, and now we've got another CH2, and now there's the bond that's formed. See? Now you're not there yet because your product is actually this simple aldehyde here. So now to go from this alcohol to this aldehyde, this is a primary alcohol to an aldehyde, and hopefully you see that as an oxidation that uses PCC or PDC. Okay. So just to review, look at your target molecule. Think which carbon-carbon bond you need to make. Don't think about functional groups yet. Think about the 2 synthons or the 2 fragments you need. Think about a positive-negative pair, and think of switching it too. After a while, you just go, oh, of course you want this to be the negative because I can see this as a Grignard, or of course you want this to be positive because I can see this as a carbonyl. Okay? So run through in your head the list of positive and negative synthons and what those groups could be, think about how they'll come together and where that leaves your functional groups. Okay? And then you go back to the basics. You identify your positive synthon and your negative synthon. How do you produce them from the starting materials? Okay? Put them together and just make sure that you've got the right functional group at the end. I hope that was useful. Thank you.